Good morning. This says no sound. Hopefully we're good. I think we're good, right? We got a microphone? Hopefully. So today, welcome to week 2, and today we're going to talk a little bit about pollution, finish up what we were talking about last week. So this lecture is about pollution control measures, some of the things that can be done, and some of the laws that are in place, and why we have to do something about pollution. So we'll explain some of the strategies and techniques for controlling some of those criteria pollutants that we talked about, and then describe some really innovative pollution control measures. So your job is to pick up on that information today. All right, so pollution control includes prevention, technology, and then innovation. So we still are working to engineer ways in which pollution can be mitigated in even more effective and more efficient ways. So obviously, ways to avoid air pollution, avoid emissions in the first place. Like don't drive a car, ride a bike, if you can, if you're close enough. But it's not always realistic. That is not necessarily the situation that you're in. Use cleaner fuel. So not using diesel, not driving a really old classic car. We'll kind of talk about some of those technologies. That would increase efficiency. And then control pollutants after combustion. There's some really key components personally that you can be aware of, but then that's where we really get into like industrial control of pollutants entering the air. Okay, so I just wanted to go over some of like the why behind this. And so what I have here, I have a link for you. I'm going to go ahead and click it, and it'll take us over to that link. And give me a second. Okay, so here, let me hit play. We have a picture from a satellite. So this is what we, put satellites up in to orbit with these really specialized cameras that will then take and put together composite photos, specialized photos of what's happening from space. And this is a aerosol optical depth composite of a bunch of videos over time-lapse and put together to make really like a picture of what's going on. So the stuff that you see that's red, that's say like blowing off of the Sahara over here, that's dust. And then you can see organic and black carbon. So anything that's coming up, organic material. So that's what's picking up on carbon. That is green. Sulfates are in white, and sea salt is in blue. So just to give you an idea of what's shifting. But these are aerosols. And this is a composite picture. I mean, it's from 2006, and so every year that's going to be changing. Let's go ahead and go back. So anything that's floating around in the air, we refer to, as aerosols. So pollution control is looking at this as data and saying like, hey, there are some really toxic materials that are just freely flowing around the earth. Like, how do we actually make sure that our human activities are mitigated to the point that that's not affecting people's health, or that we can bring that effect to something that's manageable? Because right now, worldwide, we've talked about some of the statistics. They're really high in areas of pollution. Have really high pollution. We see a lot more heart disease. We see asthma as an issue. There's like birth defects and learning disabilities and all of the stuff that's been associated with high pollution rates. So these are some of the industrial technologies that are in place, and even the personal use technologies that are in place for dealing with large output of particulate matter, of nitrogen oxide, of sulfur dioxide, all of these components. So we'll take a look at this. So some of the ways that emissions can be controlled is, well, number one that's on the list, remove sulfur dioxide from coal by fluidized bed combustion. Now, I've talked about before, like in California, we don't burn a lot of coal for electricity, but there's a lot of other places in the world that uses coal primarily for electricity production. And when you are putting out in mass amounts sulfur dioxide, it's going to have an effect on the ecosystem. And if it's affecting the ecosystem, that's going to affect human health. So this is one technology to be aware of. This is fluidized bed combustion. Now, it's a complicated system. In fluidized bed combustion, there's crushed coal, often mixed with something like limestone or other dolomite, other rocks. Okay, so it's crushed to really small pieces, like 6 millimeters or less, and then it is air's forced through it and it's bubbled, and then it's super duper heated, like 1,000 degrees Celsius, so almost 2,000 degrees per second, and all the volatiles are just like instantly, cooked out of the coal, and there's like a residual char, but then it's burned as well. And then what happens is that this like pressure and the steam's heated, right? And then there's like all this air pressure, and then there's like dust collectors, and this fly ash is an issue with coal. So there's like partially processed ash that comes off of burning coal without this high pressure, and that's like what was kind of famously known in London for like sticking to everything. And so when coal is burned in a closed container that's high pressure, it goes through a series of combustion reactions that actually make it a lot cleaner. And this helps with the coal ash not sticking to surfaces. And then there's like, ways that they've already like caught it, and they're doing, there's changes that are happening along the way before it's ever, put back out into the system. So this is something that is used for coal that has high sulfur content, because it takes a lot of pressure to burn sulfur. And then when dolomite or magnesium, calcium and magnesium carbonates, or the limestone, when that's mixed with the coal, that introduces calcium, and that calcium can then bind with the sulfates and be removed as a solid byproduct instead of as sulfur dioxide in the air. And so that's kind of how that works. And like with that calcium, it like neutralizes the sulfate, and so it doesn't become sulfuric acid. So this is a process, but it takes a lot of engineering to burn something within a closed system and make sure that it's actually closed, and that every aspect of what's going in is being taken care of on the the out end, on this exhaust end. But that's really what's necessary in order to control pollutants, and that you're going to see that there's more than just this like fluidized bed combustion, but you're going to see that even this happens in cars too. Okay, so next on the list, we're talking about installing catalytic converters in cars and what a catalytic converter is. So like I actually included a article for you to read about catalytic converters, because I don't think this is something that many people learn unless you have someone who is really good at like tinkering on cars and knows what needs to happen to maintain a car. And you sit down and have a conversation with your, I don't want to be like this, like so stereotypical, but typically it's not going to be your aunt or your mom. It's going to be like your dad or your grandpa, and you sit down and talk about how your car works and how you maintain your car. And I don't, by show of hands, I'm sure it would be not very many of you that understand what a catalytic converter is and what it's actually doing. And so there, I included an article that kind of covers what's happening in the catalyst and the changes that are taking place, and really like just using oxygen and converting, like carbon monoxide to carbon dioxide by adding an oxygen, or taking nitrous oxide and pulling off oxygen and just having nitrogen gas come out instead of nitrous oxide, which, as we talked about, leads to smog. So that's another example. Electrostatic Static precipitators is another method. An electrostatic precipitator is a filter. It's kind of a dry filter that uses static electricity, just like, you know, the exhaust passes through, and then electric, you know, ambient static electricity is used just like it, like little dust particles will stick to something when it has an electric charge like that. That's static electricity. But if humidity is off or the electrical atmosphere like that, it just doesn't work all that well. Something that works better are filters, and baghouse filters are often something that is talked about as being used to mitigate this, especially like in large industries. And so a baghouse is a really large structure that has a bunch of filters through it, and you have all these pipes and they're controlling the exhaust. What I have here, I just have a bunch of internet pictures dealing with like nuclear outputs, just big plants, okay? It could be producing a lot of different things, a steel factory. And what you see in all of this machinery is a whole bunch of what I like, you know, what kind of looks like a bunch of tubes and HVAC, and a lot of the space that's taken up, like in power plants, are in dealing with the removal of pollutants through all of these, you know, different means, these scrubbers and these filters. And so there's a lot of space required, and a lot of HVAC required. Okay, maybe it's not heating and air conditioning, but it's ventilation, and it's a controlled ventilation system in terms of like the output, so that what finally comes out of a building should be pretty clean. And this is where the EPA has really strict standards and regulations. Okay, and then one more picture is of scrubbers on smokestacks, so taking out like larger particulate matter. Here is a picture of a scrubber. It uses water. So just like it's an artificial rain system, just like when water, you know, falls from the sky, or you get condensation of clouds around particulate matter, that then it collects other dust and or particulates that are, you know, that are polluted, and those can rain out of the sky. A scrubber uses that same concept, but applies this technology to an output. So then you get clean air and then some sludge to be disposed of. Now, depending on what's in it, then this may be actually hazardous waste and needs to be taken care of appropriately. So around the world, there's a lot of different things, you know, that can be put into place, and you'll see a lot of technology and a lot of engineering surrounding dealing with pollution output from industries. And I don't know that before I started really studying environmental science that I was aware of this, and I never really thought about it. When I was driving around, you see a bunch of industrial buildings, and there's a bunch of pipes and stacks and all these, you know, tubes that take up so much space. That's really about dealing with the output, the pollution. Municipalities are like the collection of people living, right? We've tried to reduce gasoline being spilled at the pump, restrict evaporation of dry cleaning fluids. Dry cleaners were a major issue. Restrict the use of lighter fluid, restrict the use of wood-burning stoves or fireplaces. So like in some counties, there are strict regulations regarding this. Limit automobiles to every other day use, or they'll charge fees on roads, you know, like we have spare the air days. So there's a lot of strategies that are put into place by cities and counties in dealing with residential output. And that takes us through pollution. So we have both this like regulated industrial kind of stuff that's taking place, and then some strategies, you know, like even just the fees that go into driving are to try to discourage the use of automobiles and encourage the use of other means of transportation. So that is, let's see, pollution control measures.